Another problem in here, if we are going to look into this problem, the limit of sine 3x over x as your x is approaching 0 is what? So again, remember our theorem says that the limit of sine x over x as your x is approaching 0 is the same as 1. So this is what we are going to follow. So meaning, in our problem, we have to liken this one into our theorem so that it will give you a result of 1. So how is that? Meaning, we look for our multiplier so that the denominator in here, which is x, will become 3x. So if we are going to rewrite the problem, the limit as your x is approaching 0, okay, as your x is approaching 0 of sine 3x over x. Now what would be your multiplier so that it will never change the problem, but it will also give you a result in the denominator which is the same as 3x, the same as the coefficient of the sine. So definitely what we are going to use as multiplier is 1. We always make use of 1 or the definition of 1. What is that? That is the same as 3x over 3x, or that can be 3 over 3. Okay, depending of the need. Okay, so our multiplier in here is actually 3. So multiplied by 3 over 3, or that is the same as 1. So with that, when we are going to multiply these things, numerator to numerator, denominator to denominator, it will give you a statement that is the limit as your x is approaching 0, it will give you 3 multiplied by sine 3x will give you 3 sine 3x. Okay, how about the denominator? It will give you 3x. Notice that we do have now the same coefficient in here, 3x and 3x. Now one of the property of the limit is you can factor out 3 in here. So that is the same as we can have another statement, 3 multiplied by the limit as your x is approaching 0. What is left now when we factor out that one? It will give you, that is sine 3x over 3x. Notice that when you are going to look into this term, and when you are going to look into the term, this is the same as our theorem now, wherein the coefficient of sine x is the same as x in the denominator. The coefficient of sine, which is 3x, is the same as the denominator. And so, the result of this, the limit of sine 3x over 3x as your x is approaching 0 is 1. So that is the same as 3 times the result of this one, 1. So what is the limit? 3 multiplied by 1, 3. Okay? So meaning, when we are going to look for that one, look for this problem, the limit as your x is approaching 0 of sine 3x over x has a limit of 3. So that is the application of that theorem. Now again, we just try to liken this denominator be the same as the coefficient of sine. So if that is x, that must be x. If that is the same as 3x, that must be the same as 3x. So that the result will always be 1 if your x is approaching 0. Okay, so that is another problem. So now let's try to look into the next problem. Now we have another theorem in here. We have another problem that is the same as the limit of sine 7x over sine 3x as your x is approaching 0. What is the limit? Again, we are going to apply this. We're going to apply this theorem. Okay? So, when we are going to do that one, we can rewrite the problem. Okay? So, as you can see, it is in the rational form. We can rewrite the problem by having this one. Okay? The limit as your x is approaching 0 can be written as sine 7x over the limit as your x is approaching 0 can be written as sine 3x. So with that, we can apply this one separately into numerator and in the denominator by having their own multiplier. So meaning to say, if we are going to do that one, we can have another statement saying the limit as your x is approaching 0 can have sine 7x, okay, over 1 multiplied by 7x divided by 7x, okay, multiplied by 1. So as I said, we can apply this one separately to numerator and denominator. And so with that, we can also have now the denominator, the limit as your x is approaching 0 can have sine 3x over 1 multiplied by 3x over 3x. Now, how come this is our this is our multiplier? It is because our purpose is to make the denominator of sine the same as its numerical coefficient, which is the same as 7x. So that is the very reason that is our multiplier. The same as in the denominator, we are going to make the denominator of sine 3x as 3x so that we can apply this theorem. Now with that, we can have now, if we are going to multiply now, we can have the limit of multiply, that is the same as 7x over sine 7x. So multiply this one, 7x multiplied by sine 7x, that is the same as 7x sine 7x, over multiply this one, that is the same as 7x. Okay, of course, as your x is approaching 0, with that, we can also have the denominator. We can multiply that one, that is the same as the limit as your x is approaching 0. We can have that one multiply. So we have 3x sine 3x. So we have in here, how about the denominator? We have the 1 multiplied by 3x, that is the same as 3x. Okay, notice that if we continue, we can factor out 7x outside the limit. So that is the same as, if we continue, it will give you now 7x times the limit of sine, okay, sine 7x over 7x. Definitely, as your x is approaching 0. So what about the denominator? We can factor out that one. That is the same as 3x times the limit as your x is approaching 0 of sine 3x over 3x. So 3x. So n over 3x. Now notice in here, notice that this part its application now is we can apply now the theorem. So the result of that one is 1, the result of this one is 1. So we have now the result, which is the same as 7x times 1, that is the same as 3x times 1. So the result is this can be cancelled out, cancel out. So this can cancel out. So the result now is 7/3. And so notice that is how to apply this theorem. The limit of sine x over x as your x is approaching 0 is 1. So we can now say that the limit as your x is approaching 0 of sine 7x over sine 3x is equal to 7/3. Okay, so that is the problem. Okay, I hope you understand the procedure. So again, what are we emphasizing in here? This one. So in the problem such as this one, we have to liken this sine 7x and sine 3x into this form so that the result will give you 1. Okay, so I hope you got the problem. Now, to solve for the next problem, again, before we're going to solve this one, may I encourage again every one of us to please subscribe by clicking the subscribe button and watching this one until the end, so that of course you will understand how to simplify or how to evaluate or how to get the limit of the trigonometric function. Okay, so we have in here a problem. The limit of sine 3x over x plus tangent 8x as your x is approaching 0. Definitely when we are going to have the direct substitution in here, it will give you an indeterminate result. Now, so how are we going to solve for the problem? To solve for the problem, we have to simplify our tangent 8x in terms of cosine. So we can write the problem by having this one. Okay, the limit as your x is approaching 0, we can rewrite this one by saying sine 3x plus cosine sine 8x over cosine 8x. Okay, so that is how we write. Now, with that, we are going to simplify the limit before we're going to apply this one again. So how are we going to do that one? We might reduce the sine 8x over cosine 8x by what? By having again a multiplier which is 1. So what is our multiplier? Our multiplier would be, okay, we can have 1 as our multiplier, or defined by cosine 8x over cosine 8x. See, that is the essence of magic 1 or 1. So with that, we can now have another equation by saying the limit as your x is approaching 0, will have sine 3x. Okay, and then of course x plus sine 8x over cosine 8x, now multiplied by, what is our multiplier? Our multiplier is 1, or that is, we have in here cosine 8x over cosine 8x. Now notice in here that when we are going to simplify, we can multiply numerator to numerator, denominator to denominator. So with that, we can have the statement saying limit as your x is approaching 0. Now we can have new statement saying sine 3x cosine 8x. And what about this one? Multiply to the binomial. We have x, we have x, which is the same as times cosine 8x, cosine 8x, so that would be the result. Multiplied it in here, plus sine 8x, so the denominator was cancelled out. Okay, so we have now in here as our new statement. Now, for us to apply this one, sine x over x, now we have to look for a multiplier that will give you 3x as the denominator in the numerator, this one. Okay, and what about this one? We're going to have a multiplier in here that is the same as 8x. So what are the possible? Possible is 1 again, which is the same as 3x over 3x. How about in here? 1, which is the same as 8x over 8x. As I said, this can be separately applied in the numerator and in the denominator. And so with that, we can have now a statement saying the limit as your x is approaching 0 can have a statement saying sine 3x cosine 8x can be multiplied with what? 3x over 3x. And what about this one? That is the same. So we can have x cosine 8x plus sine 8x times, what's our multiplier? 8x over 8x. So again, so that we cannot be directed to any other, we cannot commit mistake, our objective is this one, we follow this one. So that notice that when we are going to multiply this one, okay, we can multiply this one in here to make it, to see to it that it will give you this statement, the limit of sine 3x over multiplied it in here. So it will give you that is the same as 3x. Okay, it will give you that is the same as 3x. Now, of course, cosine 8x. Okay, notice that we remain, this one remains. Okay, multiply, still multiplication, so that is the same as 3x. Now another one, in the denominator, we can have this one, then we can multiply this one in here, so it will give you, you can multiply the numerator. You have to remember that we can distribute the denominator. This is the same as 1. Okay, so this one, the denominator, so 8x multiplied by this one, x cosine 8x over 1, that is the same as x cosine 8x over 8x. I'm sorry. Let's consider replacing it in here, transferring it here. Okay, let's transfer it in here. So we have limit as your x is approaching 0. So this one, okay, so we have in here that is the same as sine 3x over 3x, then times cosine 8x times the remaining multiplier 3x. So what about the denominator in here? We can multiply that one. So we have in here x cosine 8x divided by 8x. So this one, okay, and plus, okay, plus we have in here sine 8x over 8x. So what is remain in the other side? That is the same as this one, 8x. So we have 8x. Now notice that if we are going to continue this one can be cancelled out with this. This one can be cancelled out. As you can see, division tayo. Okay, they can be cancelled out. So with that cancellation, we have a new statement saying the limit as your x is approaching 0, we have sine 3x over 3x times, that is the same as cosine 8x, okay, 8x times 3. Okay, what about in here? We have cosine 8x over 8 plus, we have in here sine 8x over 8x. Okay, remember that is over 8. Now applying now the properties of limit, we do have new statement now saying the limit as your x is approaching 0, we distribute now in here, that is the same as sine 3x over 3x. So this one, how about in here? That is multiplied by the limit the limit of cosine 8x as your x is approaching 0. How about this one? That is the limit of 3 as your x is approaching 0. Okay, now how about the denominator? We do have now this one, the limit, the quantity, the limit of cosine 8x over 8 as your x is approaching 0, plus how about in here? That is the limit of sine 8x over 8x as your x is approaching 0, Okay, that is multiplication. And multiplied by the limit of 8 as your x is approaching 0. Now notice that when we are going to have this one, the result of this one, this is the same as 1. How about the result of the limit of cosine 8x as your x is approaching 0? Still 1. How about this one? Constant. Constant limit, that is the same as 3. How about this one? This one, it will give you 1 over 8. How about in here? That is the same as plus 1. Notice that what about the limit of this one? That is the same as 8. So that when we continue, we have now a statement saying 1 times the limit of this one, that is the same as 1, times the limit of this one, that is the same as 3, over, how about this one? That is the same as 1/8, the limit of this one, 1/8, plus the limit of this one, which is 1. So it will give you multiplied by the limit, that one, the limit of 8 as your x is approaching 0, that is the same as 8. Okay, so it will give you now multiply, that is the same as 3. How about this one? That is the same as 9. 9 over 8 multiplied by times 8. So it will give you now a result which is the same as, you have to cancel out this one. It will give you now a result of 3 over 9, or that is the same as 1/3. So with that, we can say now that the limit as your x is approaching 0 of sine 3x over x plus tangent 8x will have a limit of 1/3. So that is the resulting limit of the problem, the limit of sine 3x over x plus tangent 8x as your x is approaching 0 is 1/3. Okay, I hope you understand this theorem and how to apply this theorem. Okay, so, and this is number 3 problem. We can have another one. Now we have another in here problem. That is the same as the limit of tangent 6x over sine 2x as your x is approaching 0. Now how are we going to get the limit of this one? In here, when we are going to get the limit, we have to rewrite again the problem in terms of cosine or sine. So this can be written as the limit as your x is approaching 0 as can factor them. You can factor them first. So that is the same as tangent 6x over 1. And the another one is we can have one over sine 2x. So that can be the factor. So that if you're going to multiply this one, it will give you just the same tangent 6x. If you will multiply this one multiplied by sine 2x, it will give you just the same sine 2x. Okay, so that is the result. Now after that one, you are now going to convert this one in terms of sine and cosine. So we have a new statement. Saying the limit as your x is approaching 0, this one can be written as sine 6x over cosine 6x, okay, over cosine 6x. And of course, that is multiplied by same, that is 1. It will give you sine 2x, sine 2x. Now, notice that we can again factor out this one, okay? Why? Because again, we are trying to apply these things so that we see to it that the denominator of the sine 6x must be 6x. So how do we multiply? Let's factor out again cosine. So in here, the limit as your x is approaching 0, the limit of this one is, the factor of this one is sine 6x over 1. What about the other one, the other factor? That is the same as 1 multiplied by cosine. Cosine 6x. So that when we are going to return it again, multiply it back, it will give you just the same sine 6x. Multiply this back, it will give you the same, that is the same as cosine 6x. Definitely, that is multiplied by 1 over sine 2x. And so that is how to do them. Now, notice that our focus is this theorem. So in here, we need to have multiplier. Again, multiplier so that we can have 6. So what would be the multiplier with our sine 6x so that it will give you a denominator of 6x? Our multiplier can be what? Can be in here 1, which is the same as 6x over 6x. Allow me to make use of another color so that we will not be confused. So sine 6x, okay? So ayan. Of course, this is the same as 1. So that is the limit as your x is approaching 0. Okay? So that is it. Now, what about in here? What would be our multiplier? So that it will give you just the same. If the coefficient of this one is 2x, the numerator must be 2x. So of course, before we look into that one, okay, and we multiply first the original 1 over cosine 6x. Okay, now we have in here 1 again, that is sine 2x. Okay, now our focus in here is again this multiplier is the same as the numerator of the coefficient of sine 6x, sine, which is 6x. So 6x over 6x to be multiplied by this one so that we can have this theorem. How about in here? The same. We'll make this one to be 2x. So what would be our multiplier? So our multiplier in here is 2 over 2. 2 over 2. Why is it that there is no x? Remember in here, when we are going to multiply this one, there is remaining 6 in here. Okay, there is remaining 6 x, and the x in here can be multiplied it in here. Okay, so if we are going to have that one, multiplying them now, we do have now the other statement, the limit of your x as your x is approaching 0, multiply it in here. So let's try to have So sine 6x, this one, that will be 6x, okay, that will be 6x. Now another one, we have now in here that is the same as 6x. Okay, multiplier is still multiplier. Okay, yan. So another one, so 1 over is of course 1. That is another cosine 6x. Yan. Now notice that we will be multiplying that one, so that is the same as 2 multiplying that one, that will give you 2, and of course that is the same as sine 2x. What remain at the other side is what? Remain is 1 over 2. So that is what remain. Okay, so again, notice that in here I multiplied it in the denominator, so we have in here what remain is 6x. So again, the 2 in here I multiplied it in here, so it will give you 2 over. Now notice that this is without x. So what is the next statement? Multiply this one. So if we are going to have the next statement, the limit of as your x is approaching 0, okay, it will give you now a statement that is the same as sine 6x over 6x. Okay, the x in here is to be multiplied in here, so of course that is multiplied by yan, over 1 pa lang yan. So notice that is the same as the limit of 1 over cosine 6x. Okay, so again, how about in here? That is to be multiplied, so we have now 2x. In here now, you can have now sine 2x. Okay, so of course this is remain to be 1/2. This is remain to be 1/2. Okay, so that remains to be 1/2. Now let's continue. When we are going to continue that one, we can have now the limit as your x is approaching 0 of sine 6x over 6x times we have in here the limit of 6 as your x is approaching 0 times the limit as your x is approaching 0 of 1 over cosine 6x. Okay, and of course the limit of that is the same as 2x sine 2x. Okay, as your x is approaching 0. And of course this one, the limit of 1/2 as your x is approaching 0. Okay, so that would be the result. Now you can now substitute. We can now have the direct substitution. Let's continue in here. So we have in here, so what is that? That is 1 times, what is that? 6 times, what is that? 1. Okay, what is that? Times 1. What is that? Times 1/2. Okay, the limit of the constant. So result, 1 times 6, 6 times 1 times 1, 6 times 1. We have in here 6 over 2. The result now is 3. And therefore we can say now that the limit is 3. So with that, we can have this statement saying the limit as your x is approaching 0 of tangent 6x over sine 2x is what? 3. So that is the result. I hope you understand how to apply the theorem regarding this limit on sine trigonometric function, that is the limit of sine x over x as your x is approaching 1 is equal to 1. Now again, may I encourage you to please subscribe and apply what you have learned in here in your classes or in your lessons. Thank you so much and more power.